Hey there, hi there, ho there. Welcome to Unit 2, Plate Tectonics. So, long story short, last unit we talked about how the Earth formed. Towards the end, we talked about the crust of the Earth, how it's kind of broken up into plates made up of different types of crust, continental and oceanic crust. So what we're going to talk about in this, this unit is how those plates move around. What is the reason behind that? What geology is created in this whole process. So here's how we know that plate tectonics is a thing. A few 100 million years ago, the continents looked like this. This is Pangea, or sometimes pronounced Pangaea. Pan meaning all, Gaia or Gaia meaning goddess Earth. So all Earth. So at one point, Pangea was the supercontinent. All the continents of the world were kind of smushed together into one large single piece. Well, how do we know that? How can we figure out that this is what the Earth looked like in the past? Well, it took evidence, and it wasn't until almost recently, within the past 50, 60, 70 years, that we were able to figure this out. This is not the only time that the Earth had formed supercontinents. That happened a number of different times. Excuse me. This is just the last and most recent of the supercontinents on Earth. If we were to superimpose modern-day countries onto Pangea here, excuse me, my goodness. United States is right here. Look at that. We would be neighbors, not only with Canada and Mexico, but with a number of countries in Africa, Morocco, Mauritania, some of them smaller ones. Cuba would be shoved right up into New Orleans, and Florida would be touching some different countries in South America, Guyana, some other ones. So this is kind of, to imagine modern day Earth, this is what it looked like. So you have Asia butted up against North America, South America, Africa, Antarctica, Australia. Look, India and Tibet and Pakistan are all down here. I don't know if you know this, but they're actually part of Asia now. So some stuff must have gone on. If this is what the Earth looked like in the past, but it doesn't now, things must move. So let's talk about the development of plate tectonic theory. Remember, watch that word, highest level of knowing. We don't throw that word around loosely. Let's go back to this steely-eyed German polar researcher slash geophysicist slash meteorologist, Alfred Wegener. He's the originator of the concept of continental drift, and he came up with this in 1912, so just over 100 years ago, that states the continents are slowly drifting around Earth. He had no evidence besides the shapes of continents. He was literally looking at an atlas, a book with a bunch of maps in it, and he noticed that the outlines of some of the continents seemed to fit together. So he cut them out and kind of mushed them together, and just based on the shapes, he said, you know what? Wow, it looks like these fit. Looks like they must have been together at one point. They're not now, therefore continents drift around. Hence, continental drift. This was not a theory at this case. This was just kind of just a concept based on, again, shapes. So this is an early map of Pangea created by Alfred Wegener, according to his imagination at the time. But he wasn't, too far off. Africa, South America, North America, Europe, and Asia. He kind of, this is kind of where he had it off a little bit. Antarctica, Australia. So, and then, again, this is just based on shapes. That's all he had going at this time. For instance, looking at South America and Africa. You look at these two continents now, it looks like they fit. There's some gaps in between, but maybe there's not really gaps. Maybe there's other stuff we're not quite seeing. So this was just his concept, his idea at the time, continental drift. It took a number of scientists decades to kind of put together the evidence, find the evidence, put it together to come up with plate tectonic theory. So that's what we're going to do next section. We'll pause here. So we're going to look at the evidence that supported the plate tectonic model that would eventually lead to the plate tectonic theory, focusing on Pangea or Pangaea and the formation thereof. I'll see you back here in just a second.